So first unit is a pseudo MOS design. So main concentration of first unit is pseudo NMOS logic. So here construction of pseudo NMOS logic inverter means you have to explain the operation of pseudo NMOS inverter. You know symmetrical condition, you know circuit diagram. What are the input? Input is 0, which transistor is on, which transistor is off, what is the output? For input 1, which transistor is on, which transistor is off, what is the output? Because it is inverter, for 0 input you will get 1, for 1 output you will get 0. That operation you have to explain if the question is asked on pseudo NMOS inverter. So compute inverter threshold voltage logic for pseudo NMOS inverter. When both the transistors are in saturation region, we are finding the threshold voltage equation. Output high voltage and output low voltage. So this also I explained VOH, VDD. So analyze the gain of threshold voltage means V0 by Vi of pseudo NMOS inverter I explained. Calculate transient response, rise time, fall time. So TR, TF I explained. Construct pseudo NMOS logic gate means for I showed for exclusive OR gate how they constructed, and for NAND gate, NOR gate, for AND gate how to draw a pseudo NMOS logic gate. You know, if any Boolean equation is given, how to draw a pseudo NMOS logic, that you know. I think it is same as CMOS, but pull down network is same as CMOS. Load only single, that is pseudo MOS will be there. So that is the difference. So standard question they are asking is exclusive OR gate. Construct exclusive OR gate using pseudo NMOS logic gate. And discuss transistor equivalency. Means in the pull down network, if 5 or 6 or 10 transistor circuit given, means that you have to constructed using single transistor. So transistor equivalency also I explained yesterday. And remaining topic in the syllabus book is CMOS explain CMOS inverter logic and realize logic design. Realizing means if a Boolean equation is given, for that you have to draw a CMOS logic design. You know, pull down network and gate multiplication means series, uh, and addition means parallel. In pull down, pull up means multiplication means parallel, uh, addition means series. So this already you learned in the VLSI for NAND gate, NOR gate, how to draw using CMOS logic. So you should know CMOS inverter logic. So that I will just discuss, that I was already given as a assignment question to you. Once you know this, I will draw all the inverters. This is pseudo NMOS inverter. This is gate, this is source, this is drain, this is gate, source, drain, this is V out. This is pseudo NMOS inverter. CMOS inverter is V in, VDD, V out. This is ground, this is V out. What is the difference between pseudo NMOS inverter? This is inverter point of view. Here gate is biased to VDD by 2. Here gate is connected to V in of both the gates are connected to V in. That is the difference between pseudo NMOS inverter and CMOS inverter. Suppose only NMOS inverter. For only NMOS inverter means this is input. Here we have to connect resistor. This is VDD. This is V out. And this is ground. So all load CL is connected. Load capacitance for all. CL for all load capacitance is connected. So another, so many inverters are there. So another inverter is depletion load NMOS inverter means here this is depletion MOS transistor. This is shorted like this. Here you will get input. Here you will get ground. Here you will get VDD. Here you will get V out. So this is depletion load NMOS inverter. This is basic NMOS inverter, and we can also connect here current source. So for all this circuit, input 0 means output is 1, input 1 means output is 0. In your syllabus book, first unit they concentrated more on pseudo NMOS inverter, and they also concentrated on CMOS inverter, and this inverter will come in the second unit. And this basic NMOS inverter you should know from the previous classes. So what is the operation of CMOS inverter here? If they ask, explain the operation of CMOS inverter in the exam, first you have to draw this diagram. CMOS inverter, this is gate, source, drain, gate, source, drain. After that, you have to explain the operation. When Vin equal to 0, NMOS what happen, PMOS what happen. NMOS is, when Vin equal to 0, NMOS is off, PMOS on, and NMOS is cut off or open, PMOS short. Then output is connected, a path is formed between VDD to ground, and capacitance CL will be charged. When Vin equal to VDD or Vin equal to high, NMOS on, PMOS off, and it is short, it is open, and a path is formed between V0 to ground. Then the capacitor, if before it is charged, means it is discharged to 0. So like that operation you have to explain for any inverter. For this inverter operation also, when V in equal to 0, which transistor is on, which transistor is off, the output is connected to VDD or ground. For V in equal to 1, which transistor is on, which transistor is off, and output is connected to VDD or ground. That operation you have to explain, either pseudo NMOS inverter or CMOS inverter. So here one thing you have to understood is the output graphs are same for any circuit. That may be pseudo NMOS inverter, that may be CMOS inverter, that may be depletion load NMOS inverter. Suppose DC analysis means x-axis is swept, this is the input, x-axis is swept with voltage 0 to VDD, means x-axis is fixed, x-axis we can't take current, we can't take time. If x-axis we are sweeping with voltage from 0 to VDD, then output what you will get is like this for any inverter design. That may be pseudo NMOS inverter, that may be CMOS inverter, that may be NMOS inverter, that may be depletion load NMOS inverter. So for any inverter design, you will have 5 region of operation. This is also out voltage V. So up to here one region will be there, up to here another region will be there, exactly here another region will be there, from here to here another region will be there, from here to here another region will be there. So this is region 1, this is region 2, this is region 3, this is region 4, this is region 5. So for any inverter operation, transistor will go into 5 region of operation. Suppose if you take in the operation explanation, you have to draw DC analysis graph and transient analysis graph. So transient analysis means this is the x-axis time, y-axis may be out voltage or current or power. So I am drawing with respect to voltage, and this is the inverter. This is transient analysis. If operation they asked in the exam, this is VI, this is V out, this is VI, this is V out. So this is DC analysis, this is transient analysis, because x-axis is time. Suppose AC analysis for CMOS inverter means frequency you will get. Here you will find V0 by Vi gain. Gain you will get like this. Here also 5 region of operations will be there. Exactly here, here, here. This is region 1, region 2, region 3, region 4, region 5. So this is AC analysis. So these graphs are common for any inverter design. Sir, some of the students asking Zoom link of this college website is not working properly. So I sent through LMS, no? Uh, this is a general, these are the generalized graph for any inverter. So this is DC analysis graph. This is tangent analysis graph. This is AC analysis graph. From AC analysis means with respect to frequency. Transient analysis means with respect to time. In DC analysis means with respect to VDD. Output may be voltage, current or power. Output may be voltage, current or power. Output here is gain. So from this, what are the parameters you are calculating in our first unit is you are calculating threshold voltage, VOH, VOL. From VOL, from these three, you can calculate noise margin. And from here, you can calculate rise time, fall time. From here, you can calculate gain. So this point is nothing but operating point, and this is VDD by 2, or this is nothing but threshold voltage. Finding threshold voltage of any inverter design. For pseudo NMOS inverter design, you are finding threshold voltage. For CMOS inverter also, at this point only threshold voltage you will get. So threshold voltage is approximately equal to VDD by 2. So if you, in the problem, if you are finding threshold voltage, it is approximately equal to VDD by 2. Likewise, also you can eliminate options. Threshold voltage means it is approximately equal to VDD by 2. So at this point, both the transistors are in saturation region. That is region 3. This is region 3. You take CMOS inverter. You take CMOS inverter or pseudo NMOS inverter. At this point, this is saturation. This is saturation. If you take CMOS inverter also, this is saturation. This is saturation. Input equal to threshold voltage, output equal to threshold. Here also input equal to threshold voltage, input equal to threshold voltage. We have to equate PMOS current, PMOS saturation current, NMOS saturation current to find out the equation of threshold voltage. Here also we have to equate threshold voltage, PMOS saturation current equation, NMOS saturation current equation, because when both are on, constant DC current will flow. Then we have to equate both the current. So to find out threshold voltage, at this point, both the transistors are in saturation region. If you equate both the transistor saturation current equation, you can find the threshold voltage equation. Then here we have to find VOH, high voltage. So at this point, if you go for pseudo NMOS inverter, NMOS is off and PMOS is off. PMOS is linear. NMOS is off, PMOS is linear. So here also same, NMOS is off, PMOS is linear. So finding VOH, both the transistors for CMOS inverter design, for NMOS inverter design, this is the condition. If you check the conditions also, you will get this only, because 0 means NMOS off. Here 0 means NMOS off. Then PMOS here is linear. And here you have to find VOH, VOL. At this point, if you take CMOS design, PMOS off, NMOS, PMOS off, NMOS linear. PMOS is off, NMOS linear for CMOS design. But if you take pseudo NMOS inverter, because this is biased to VDD by 2, this is not off. That's why here PMOS, while calculating pseudo NMOS inverter, you will get saturation region. So I will differentiate clearly region of operation for pseudo NMOS and for CMOS inverter. This is CMOS inverter. pseudo NMOS. So this is input signal. We are varying from 0 to VDD. So here you will get VTN exactly middle. You will get VDD by 2. Then here you will get VDD minus VTP. Here VDD. Here also same. For DC analysis, because it is inverter design, graphs is same. G0 VTN threshold voltage of NMOS. This is VDD by 2 or threshold voltage of circuit. This one. Here you will get VDD minus VTP. Here you will get VDD. Here you will find VOH. Here you will find VOL. Here you will find gain and threshold voltage. Here you will find gain and threshold voltage. This is one region. This is one region. Exactly this is another region. And here to here another region. Here to here another region. So if you take CMOS inverter, region 1, NMOS of PMOS linear. If you then VOH calculation, to find out VOH calculation, you have to switch off NMOS. You have to make PMOS linear, means PMOS saturation current or PMOS resistance. That linear, from the linear current equation you have to solve VOH. So to find out VOL, here this here VOL, this is high, this is low, VOL. Then here what is happening? Exactly opposite. So PMOS of NMOS linear. This is for CMOS inverter design. For CMOS inverter design, to find out output voltage equation, you have to switch off PMOS and you have to make NMOS as linear. And to find out threshold voltage or gain, both NMOS and PMOS linear saturation. So maximum gain you will get at operating point, that is VDD by 2, and both the are saturation. Here also both are in saturation, NMOS and PMOS. Here PMOS means pseudo saturation. Here also NMOS off. Here PMOS linear. Here because PMOS is not off, PMOS is in saturation region only, NMOS linear. So while finding VOL, I told that PMOS is in saturation region, NMOS is in linear. So here saturation means here in this region NMOS saturation, PMOS linear. So NMOS of saturation, NMOS saturation. After that NMOS linear, NMOS linear. So here NMOS first switching off. After that NMOS is going to saturation region. Here NMOS is going to saturation region. Here NMOS linear. Here NMOS linear. So exactly opposite PMOS. PMOS off. PMOS going to saturation region here. PMOS here is saturation region. Here PMOS linear, PMOS linear. So this is the operation. Based on this, you can calculate threshold voltage of CMOS, gain of CMOS, VOH of CMOS, VOL of CMOS equations. So here also same. So PMOS is, NMOS is saturation, same similar to CMOS. PMOS linear. So here NMOS linear, PMOS saturation. So one difference is here PMOS is not switched off. CMOS it is switched off. That this is the difference. Remaining all same region of operation. So from this what we will find noise margin. If noise margin is nothing but NMH minus NML. NMH is nothing but VOH minus VTH. NMH. NML is nothing but V threshold voltage minus VOL. So from this we can find out noise margin. So that graph I will show. So this is the noise margin graph. This is the transfer characteristics of DC analysis. So this is VOH, this is VOL. So the NML value you will get like this. So in this range, low noise margin. If NMH value means from VOH to NMH, the noise margin range is like this. For 1, for 0, for one logic level, this is a range based on the NMH value. NMH value you will get below VOH. NML value you will get above VOL. So what is the value you will get? Based on that, the range will be decided. Margin of any inverter design. So this is a DC analysis graph, region of operation. So for if they asked in the exam, explain the operation of inverter design, you have to explain the operation. You have to draw these 3 diagrams. This is DC analysis graph. This is tangent analysis graph. This is gain graph, generalized graph. I am not assigning any values. So but these are the expected graphs. This is DC analysis, tangent analysis. This is AC analysis. So these are the any output graphs of inverter design will have 5 region of operation. Middle one is both the transistor is in saturation region. First one is NMOS of PMOS linear. Then here NMOS saturation, NMOS saturation. Here PMOS saturation, PMOS saturation. Likewise, it is defined. I think you already know. You should know this graph already from the previous in the VLSI only. You should know this one. So this is a gain graph, and this is the region 3 means both the transistors are in saturation region. At that time only you will get maximum gain. That is V naught by Vi equal to for pseudo NMOS minus GMN by 1 by RDS1 n plus 1 by RDS2. That is the equation we got, maximum gain. So this is region 1, region 2, region 3, region 4, region 5. 1, 2, 4, 5, we are not finding the gain. If you finding the gain, you will not get maximum gain. Maximum gain when you will get when it is operated in saturation region. So at region 3 only we have to find out gain. At region 3, input is identical to the output. Both the transistors are in saturation region, and at that point you will get the maximum gain value. And now I will show CMOS inverter. So this is a CMOS inverter. This already you know. And here for symmetrical output combination, in the pseudo NMOS inverter, they multiplied with 2. That is WLP by 2. But here 2.5 times or 1.5 times. So they are taking 1.5. The ratio of WLP1 by W by L2, we can they in the pseudo NMOS they taken 2. Here they are taking in the textbook 1.5. The ratio to get symmetrical output. That is one difference. In the pseudo NMOS inverter, the ratio of W by Ln W by L P by W by Ln equal to 2, but here ratio is 1.5. So to find out threshold voltage of CMOS inverter, what is the condition? Both the transistors are in saturation region. When both the transistors are in saturation region, we have to equate. 1 means NMOS, 2 means PMOS. This is saturation current of NMOS. This is saturation current of PMOS. So according to VGS minus VT from the circuit diagram. So here VGS is nothing but VDD minus Vin. So that only they substituted. So if you equate these two equation, you will get threshold voltage equation like this, similar to pseudo NMOS inverter, but the circuit is different. See, this is CMOS inverter. So this I was given as assignment. Find out threshold voltage of pseudo NMOS inverter. So you should know both the transistor saturation region. Both the transistors are in saturation region. V in equal to VTH, V out equal to VTH. This ratio should be 1.5 times. VDD, they are taking 3.3 volts, or VDD. Generalized equation means VDD only they will take. So they are finding equating saturation current of PMOS, saturation current of NMOS, and they are replacing VGS from this circuit diagram, VDS and VDS also from this circuit diagram, and they substituted here and they equated. After equation, you will get like this, and this is a problem. So here in the problem, W by L2, W by L1 means this is PMOS by NMOS. So that ratio they substituted 1.5 here. In pseudo NMOS they substituted 2. And VDD supply voltage, VTN threshold voltage of NMOS, threshold voltage of PMOS. 2 means P, 1 means N. So mu P by mu N they given. So after substituting you will get VThevenin equal to 1.2, and this is approximately you will get VDD by 2, because 3.3 divided by 2 is 1.62, and threshold voltage you are getting as 1.40, and this difference is getting because of W by L ratios and mu P mu N they given differently, that's why. But approximately we will get VDD by 2 threshold voltage. So expected answer is VDD by 2 approximately. 1.40 means it is approximately VDD by 2. So this is right. So to find out the gain of CMOS inverter means same. Both the transistors are in saturation region. Input is threshold voltage, output is threshold voltage. We have to draw small signal graph for both NMOS and both PMOS, and same concept we have to apply. And what is the difference you will get is here in CMOS, this is added, that's all. In pseudo NMOS, GMN by 1 by RDS1 parallel plus 1 by RDS2. In CMOS, you will get GMP. That is the difference. So this I was given in the assignment. So if you read, you will understood easily. If you understood pseudo NMOS inverter, same thing you have to apply for CMOS inverter. What is the difference between pseudo NMOS inverter and CMOS inverter is, here gate is biased to VDD by 2 in pseudo, but in CMOS gate is connected to VIN. So when like this connection is there, you will get threshold voltage of inverter like this, and gain of inverter, final equation like this. And 1 by RDS1, 1 by RDS2, same equation. 1 by lambda n IDN saturation, 1 by lambda p IDN saturation. 1 means NMOS here. So ID1 means IDN saturation current you have to take. Then GM we can we have two formulas. Any of the formula you can substitute. So based on that, they calculated the gain of pseudo NMOS inverter. You will get expected graph like this only. Here you will get gain frequency. This is V0 by Vi. Here for CMOS inverter, you have to draw GM1 plus GM2 minus 1 by RDS1 plus N plus 1 by RDS2. So GM of pseudo NMOS minus 30 dB they got. Here they got minus 40. So magnitude wise, CMOS gain is more. Gain of CMOS is more. Suppose for the given problem, if you see here magnitude you got is minus 40. Now transient response. Here finding VOL is not given in the textbook. You solve by your own. Finding VOH, finding VOL. So that noise margin calculations we need VOL, VOH. VOH is nothing but a VDD. In both in CMOS, both in pseudo NMOS, VOH equal to VDD. You have to find VOL. Finding VOL in CMOS inverter, what is the region of operation? To find out VOL in CMOS inverter, here this is to find out VOL. What is the region of operation? PMOS of NMOS linear. So it is very easy. PMOS of NMOS linear. So we have to find out. So threshold voltage, gain. Okay, then DC analysis will be over. If you find out VOH, VOL, threshold voltage, noise margin, then DC analysis parameter finding will be over. Then another parameters you have to find is tangent response. Tangent response means with respect to time. With respect to time, the parameters you have to find out is rise time and fall time. Rise time, fall time. So during rise time for pseudo NMOS inverter, for CMOS inverter, region of operations both are same. During rise time, what is happening? NMOS is off or on. During rise time means input is rise time means 0 to 1. During rise time, what is happening? NMOS is off because input is 0. NMOS is off, PMOS is in active region. So in CMOS also same. During fall time, PMOS is off, or if the current in PMOS is very low, it is neglected. NMOS active region. So fall time. During fall time, these are the region of operations. So for that, they will find out R equivalent 1 means NMOS. So they will find out like this. For CMOS, R equivalent 2 means how to find out R equivalent resistance in the pseudo NMOS design I explained. You have to equate saturation for saturation current of NMOS. You have to take and you will get this one. And saturation current of PMOS you have to take and you will get this one. And this is generalized equation for fall time or rise time. For rise time also you can write this equation, and the n for fall time here it is p, that is the difference. And v out of infinity in rise time is 0 or VOL. This is VO of T1 means during fall time 70% of VDD. This is 70% of VDD, and this is 10% T1, T2, 10% of VDD. This is VOL. V out of infinity means VOL. But during rise time, we have to substitute here R equivalent P equation, load capacitance equation, Ln. V out of infinity means VDD during rise time. V infinity is VDD, and VT1 is 10% of VDD, V22 is 70% of VDD. That values you have to substitute and you have to find out rise time and fall time. This is one type of equation. Another type of equation here is, here they substituted, they taken supply voltage 3.3 volts. If they substituted, finally they will get, they replaced this with 1.2. This is fall time. This is rise time also same, 1.2 they got, R equivalent into CL. So T rise time you will get in CMOS is 1.2 into R equivalent into CL after substituting values. So T fall equal to 1.2 into R equivalent into CL. So this they taken VDD equal to 3.3 volts, VOL equal to 0 volts, I think in CMOS. VOH equal to. So after substituting those values here, during fall time you will get 1.2. During rise time also you will get 1.2, this one, and they are finding R equivalent C1. So fall time you have to substitute R equivalent N. Rise time you have to substitute R equivalent P. 2 means P. So based on the given problem, you can find out, suppose for a CMOS inverter, find the approximate CMOS inverter they asked. So whether they are asking for inverter, whether they are asking pseudo NMOS inverter, first you have to check. After checking this, if they are asking rise time or fall time, you have to check. CMOS inverter rise time formula is, we can substitute here 1.2 R equivalent into CL and 1.2 R equivalent into CL. R equivalent value they before problem they calculated. R equivalent of NMOS means from this R equivalent NMOS they substituted here and they got some kilo ohm. They substituted in this and they got some kilo ohm. After getting the values in kilo ohms, in load capacitance that kilo ohm they substituted means they will get fall time as like this, rise time as like this. And another equation also in the pseudo NMOS inverter you learn for rise time is R equivalent into PMOS for rise time, del VD change in base ID P saturation. So this is also in this equation also you can substitute. In this equation also you can substitute. Fall time means R equivalent into NMOS change of 70% change in voltage by ID and saturation. So in pseudo NMOS inverter design, how this Q equal to CV, uh, Q equal to, from this Q equal to IT, T equal to Q by I, CV by I. So same formula. Change in voltage C by I. So here load capacitance you will get. Here load capacitance you will get. CL into change in voltage by I. CL into change in voltage by ID and saturation. In this formula, you can substitute. Otherwise, this equation, from this equation, this modified this equation like this. If supply voltage is given 5 volts, then it may be changed. So based on 3.3 volts, they taken 1.2 RC. Which R you have to substitute, you should know. Either NMOS resistance or PMOS. One means NMOS, P means CMOS. P means 2 means PMOS. So this is about how to calculate threshold voltage of CMOS, how to calculate gain of CMOS, transient time, fall time, VOH equal to VDD. I think VOL equal to 0 volts you will get approximately. So that you have to do assignment. So this is about CMOS inverter. Up to here, any doubts is there? So this is in the, this is syllabus book. Here they are asking pseudo NMOS logic inverter, threshold voltage, high voltage, low voltage, gain, transient response, rise time, fall time, how to construct a pseudo NMOS logic for a Boolean equation, and if any big circuit is given in the pull down network, how to replace with a single transistor. Here CMOS inverter logic, and how to draw CMOS logic for a given Boolean equation is already you know. And here I explained to find out threshold voltage, how to find out threshold voltage, how to find out high voltage and low voltage, gain, transient time and rise time for CMOS inverter. Same concept which is applied to pseudo NMOS inverter, you apply to CMOS inverter, solve it and take that as an assignment. My explanation part is over and your assignment part is remaining. Find out threshold voltage, gain, transient, rise time of pseudo NMOS inverter as assignment. So up to today class, today I am closing first unit. If you have any doubts in the first unit, you can ask me in the chat box. So entire unit depends on this only. So you should know the circuit diagram first. Before that, you should know current equations of linear current and saturation current equation of NMOS and PMOS, both linear and saturation current equations of NMOS and PMOS. So based on the parameter, you are calculating what is the region of operation that you should know. If you are finding output voltage VOH, region of operation is 1. If you are finding the output voltage low, region of operation is 5. If you are finding the threshold voltage, region of operation is 3. And these two regions we are not finding. This is switching, in between switching. VOH to operating point to VOL. This is a switching point. Then same for PMOS also. If any inverter you take, this is a DC analysis graph. Every DC analysis graph has 5 region of operation. From this we are finding noise margin. Then from transient analysis, mainly we are finding transient time, fall time. And gain also we are finding. Gain means AC analysis. From AC analysis, we can find out actually 3 dB gain bandwidth. That concepts are not there. The main parameter you are finding from this is gain. So in the lab, if you want to find out the gain of CMOS inverter in the lab, suppose if you want to find the gain of any inverter design, first what you have to do, you have to do DC analysis. If you do DC analysis, you should get graph like this. If you vary the input exactly VDD by 2, you should get. Sometimes you may get like this, not exactly VDD by 2. So at that time, you will not get maximum gain for that circuit parameter. So adjust the circuit parameters in such a way that it should intersect at exactly VDD by 2. Means you can vary the width, you can vary the input biasing, vary and make sure that the DC analysis graph should exactly intersect at VDD by 2. After checking this, then if you find out, then go for AC analysis. Then you will get maximum gain value. Without checking this exactly intersecting VDD by 2, if you find out the gain of the circuit, you will get less gain. So if your aim is to find the gain of any inverter design, in the DC analysis, you have to set the parameters to get the output voltage and input line should intersect exactly at VDD by 2. If it is intersecting means both the transistors are operating in saturation region. Suppose if it is intersecting like this, one is in linear, one is in saturation region, like that you will get. So if it is input graph is intersecting like this, one is off. So exactly this should be intersect at the VDD by 2. Then only it is confirmed that both the saturation are in, both the transistor are in saturation region, you will get the maximum gain. So from the lab point of view, when you want to find the gain, then while performing DC analysis, make sure that this is intersecting exactly at VDD by 2. If it is not intersecting, you can do sizing, or you can change the input biasing or supply voltage, like that parameters you can change, and make sure that it should intersect exactly at VDD by 2. After that, you go for the AC analysis, then you will get gain. Transient analysis you already know. In the lab you did. I think in the lab, in the mentor graphics lab, DC analysis and AC analysis you are not doing. Actually, these 3 analysis you have to do for inverter design. So for amplifier means, for amplification designs, you have to do DC analysis, ACD analysis. For digital design, we are going for only transient analysis, because just we are checking that circuit is operating according to the design or not in transient analysis. But if you are going for amplifier design, gain should be high. At that time, all the transistors should be operated in saturation region. For that, you have to check DC analysis graph exactly it is operating at VDD by 2. If it is operating at VDD, intersecting at VDD by 2, then all the transistors are in saturation region, then you will get maximum gain. So this is a lab point of view. So once again, I am telling, if anybody asks operation of inverter design, first you should draw circuit diagram. First, after that you have to explain the operation. Operation means transistor on off, where the path it is connected. After that you have to draw DC analysis graph, transient analysis graph, gain graph, and region of operations. If you show, then effectively you will get good marks. So this is about inverter operation of pseudo NMOS inverter and CMOS inverter, and finding parameters. This is for this I explained for pseudo NMOS inverter. Now I give an assignment for to find out CMOS inverter. So CMOS inverter, pseudo NMOS inverter, both the transistors are saturation region, threshold voltage equation you will get like this. VOH you will get VDD or equivalent, while finding VOH you will get like this. For VOL you will get, this is the equation at that time, NMOS linear, PMOS active. This is noise margin, and this is gain GMN by 1 by R, and gain GMN is mu n CYW by VGS minus VTN. This rise time, fall time. So this is explained for pseudo NMOS, and for CMOS also I explained with the region of operation. And you have to solve the equation, that is assignment I was given. How to solve also I explained orally. Mathematically with pen you have to solve on the paper and you have to submit to me. But orally I explained this concept for CMOS also. And another thing is, for a given equation, how to draw pseudo NMOS inverter, how to draw CMOS inverter, you should know. And transistor equivalency concept also you should know from the first unit. So if you know all this topic, I can close first unit. I hope maximum information I was given from the first unit. If you have any doubts, you ask me in the chat box, otherwise you can leave. I'm waiting for from next Monday onwards I will explain second unit. So if you have any doubts, in the first unit you can explain, you can ask.